Have you ever stopped to think about the hidden engineering that makes things like electric cars so quiet? Or how industrial robots move so smoothly?
It often comes down to components you never see, really precise parts.
Exactly. And today, we're doing a deep dive into a key part of that, the global market for gear honing machines. We've got this great market analysis from cognitive market research, and our mission is to pull out the key insights for you.
Right. So gear honing machines, what are they? At a high level, they're specialized tools, very high precision.
Yeah.
They're used after gears are hardened. It's a finishing step. Their main job is to improve the gear's surface, make it smoother, which cuts down noise and makes the whole transmission more efficient.
So super critical for performance.
Absolutely vital for that final level of refinement.
And that refinement, that precision, connects directly to things you experience every day, right?
Definitely. Think automotive, especially EVs like you mentioned, but also aerospace, general industrial machinery, robotics. It's foundational stuff.
These machines are basically enabling the next generation of transport and energy systems, often behind the scenes.
Precisely.
Okay, let's unpack this a bit more then. We know what they are, roughly. But how do they achieve that, microscopic level of perfection? And why is honing specifically so important for these high-tech sectors?
Yeah, it's fascinating. It's not like basic grinding. After you harden metal, like a gear tooth, you get tiny distortions, almost invisible imperfections.
Like little wrinkles?
Kind of, yeah.
Hmm.
And gear honing machines basically smooth those out. They use abrasive tools, not cutting tools, to remove minuscule amounts of material. We're talking extreme precision.
Ah, okay.
This ensures the gear teeth mesh perfectly, are super smooth. That's key for quiet operation, think EVs again, and for efficiency. Less friction means less wasted energy, whether it's a wind turbine or a robot arm.
That makes a lot of sense.
Yeah.
So given how specialized this is, what's really driving the growth in this market? Where's the demand coming from?
Well, the research points to three main things. Number one, no surprise, the huge boom in electric vehicles. They need those quiet, efficient gearboxes we talked about.
Right.
Second, just a general need across many industries for higher precision mechanical parts, medical tech, advanced manufacturing, you name it.
Hmm.
And third, there's a big push everywhere for more energy-efficient manufacturing. These machines help create parts that just work better, waste less energy.
And the numbers, they really back that up, don't they?
They do. The report states the global market hit about $1,238 million in 2021.
Okay, 1.24 billion, roughly?
Yeah, and it's projected to grow quite significantly. By 2033, the forecast is $2,884 million.
Wow, more than double.
Exactly. That works out to a compound annual growth rate, a CAGR, of 7.3% between 2025 and 2033.
So what does that tell us? It's not just niche, it's robust, sustained growth. It shows how much industries are prioritizing quality and efficiency right down to the gear level.
Precisely. It's a sign that these enabling technologies are becoming really central.
Okay, let's break down where this is happening. The global picture is one thing, but the regions look quite different, starting with North America.
North America is a big player. The market there was already over $523 million in 2021.
Mhm.
It's expected to reach almost $11,185 million by 2033. That's a solid CGR of just over 7%, 7.078% to be exact.
So strong and steady growth there.
Very steady. And the U.S. dominates, no question. Its sales were about $423 million back in 2021, heading towards $928 million.
Okay.
But what's really interesting is the growth rate in Canada and Mexico. Canada's CAGR is projected at over 8%, 8.076%, and Mexico is even slightly higher, 8.153%.
So while the U.S. is the biggest market by far, the others are actually picking up pace faster.
In terms of percentage growth, yes, it suggests, maybe expanding manufacturing hubs, perhaps automotive or aerospace investments in those countries.
Interesting. Okay, let's compare that to Europe, the traditional industrial heartland. How does it look?
Europe's also a major market. It was about $318 million in 2021, projected to hit $715 million by 2033.
So again, more than doubling.
Yeah, with a CGR just under North America's at 6.927%. Germany, as you'd expect, is strong, 7.373% CAGR. The UK actually looks quite impressive at 7.575%.
Okay.
But here's that interesting pattern again. The rest of Europe category shows a really high CAGR. We're talking 9.726%.
Over 9.7%. What does that usually point to?
It often means rapid modernization or big investments in specific, maybe smaller European economies. Could be new EV plants, automation drives, things like that, happening outside the biggest players.
Fascinating. Okay, let's pivot to Asia Pacific. That region often comes up as a huge growth engine.
And it definitely is here too. Sales revenue was around $249 million in 2021,
Mm-hmm.
projected to hit over $620 million by 2033. That's a regional CAGR of 7.795%, so a bit faster than North America or Europe overall.
And who are the key players driving that in APAC?
China is massive, of course. It was about $86 million in 2021, projected to reach $222 million by 2033. That's an 8.077% CAGR. Japan is also significant, more than doubling its market size by 2033 with a 7.2% CAGR. India is growing fast too, 8.625% CAGR. Really shows that industrial expansion.
And you mentioned a standout.
Ah, yes, Taiwan. If you look at individual markets, Taiwan's growth rate is remarkable, a CAGR of 9.394%.
Nearly 9.4%.
Exactly. It really highlights its critical role in high-tech manufacturing and the electronic supply chain. They need that precision.
Absolutely. Okay, let's move across the globe. What about South America?
South America shows consistent growth, started at about $63 million in 2021, expected to reach $138 million by 2033. The CAGR there is 6.747%.
Solid, if not quite as fast as some others.
Right. Within the region, Brazil leads with the 6.955% CAGR, and Argentina is actually a bit higher at 7.356%, likely tied to automotive and agricultural machinery demand down there.
Makes sense. Okay, next up, the Middle East.
The Middle East is seeing quite a surge. It was about $56 million in 2021, but it's projected to hit nearly $140 million by 2033.
Another region nearly tripling.
Yeah, with a strong CAGR of 7.884%. The UAE stands out with 8.574%, likely due to their diversification efforts into advanced manufacturing.
And let me guess, the rest of Middle East category.
You guessed it. It has the highest growth rate within the region, an amazing 9.988% CAGR.
Almost 10%. It really does make you wonder, like you said about Europe, what specific projects or industrial shifts are driving that kind of growth in these rest of areas. It's clearly significant.
It really is. There are definitely big developments happening that aren't always grabbing the main headlines.
Okay, and finally, let's round off our regional tour with Africa.
Africa actually boasts the highest regional CAGR overall, a striking 10.391%.
Wow, over 10% region-wide.
Yes. Now, the starting base is smaller, about $28.5 million in 2021, heading towards $85.7 million by 2033. But that growth rate is phenomenal.
Which countries are leading that charge?
Nigeria shows a very strong CAGR of nearly 11%, 10.9992%. And South Africa is right there with the highest individual country CAGR we've seen in this whole analysis, 11.152%.
Over 11% CAGR in South Africa. That's incredibly fast growth.
It really signals major industrial development, a rapidly increasing need for precision manufacturing, probably linked to infrastructure, maybe automotive assembly, mining tech, a range of things.
So wrapping this all up, what's the big picture takeaway from our deep dive?
Well, I think it shows that this market for gear honing machines, something most people probably haven't thought about, is actually a really significant and crucially fast-growing part of global precision engineering.
Yeah, it's kind of a hidden engine driving a lot of the technology we rely on. Quiet cars, efficient factories.
Exactly. It's proof that so much innovation happens at these fundamental, sometimes invisible levels.
It underscores how technologies we don't even see are shaping our modern world.
Absolutely. And think about this. As demand keeps rising for things like EVs, robotics, just quieter, more efficient, more precise machines everywhere, the kind of meticulous work these honing machines do is literally shaping the future of how we move and how we make things.
It really makes you think, doesn't it? What other hidden industries, what other seemingly niche technologies are out there right now quietly powering the next wave of advancements?
That's the fascinating question, isn't it? What's the next gear honing machine market waiting to be discovered? Welcome to the Deep Dive.
Great to be here.
Today we're getting into something pretty interesting, maybe a bit hidden away in manufacturing.
Mm-hmm.
Gear honing machines. We're looking at the market, the dynamics, what's trending.
Right. You might hear gear honing and think, well, that sounds super niche.
Exactly. But stick with us because this is really about the precision behind so much of the tech we use every day.
It really is.
So our mission today really is to unpack what's driving this market, what challenges it faces, and, the innovations shaping its future.
And that why it matters piece is, well, it's crucial, isn't it?
Yeah.
We think about it. Gears, they're everywhere. Cars, industrial machines, wind turbines. You name it.
The hidden workhorses.
Totally.
Mm.
And the quality of those gears, that directly affects how well a machine works, how long it lasts.
Reliability, noise even.
Exactly.
Yeah.
And gear honing, well, that's the process to get that extreme, like near perfect precision on the gear teeth.
Perfecting the core components.
Yeah, where even a tiny error like a micron can cause big problems down the line.
Right. So hopefully you'll have some aha moments as we go through this.
Mm-hmm.
You'll see how this seemingly small part of manufacturing links up with demands for quieter machines, advanced tech, even sustainability.
It's all connected.
By the end, you might just look at, the devices used differently, appreciate that hidden engineering. So, okay, what is driving this market, this seemingly obscure corner of manufacturing?
Well, it really boils down to this relentless global push for perfection, for
Mm-hmm.
precision.
Okay.
We're just seeing more and more demand for incredibly precise gears everywhere.
In which industry specifically?
Oh, automotive, definitely. Aerospace,
Yeah.
heavy industrial machinery. They're not just asking for quality anymore.
They're demanding it.
They're demanding these, like, unprecedented levels of accuracy.
And that's where honing comes in.
That is exactly where gear honing machines really show their value. They're essential for hitting those incredibly tight tolerances.
Tolerances meaning how close the part is to the design spec?
Exactly. Making sure everything fits and works just right. Plus, you get super smooth surfaces and really consistent gear profiles. Indispensable stuff. And what's really interesting is how that ties into advanced transmission systems.
Ah, okay. Tell me more about that connection.
Well, modern cars, heavy equipment,
Mm-hmm.
they can't just use good enough gears now.
Right, the demands are higher.
Much higher.
Yeah.
They need precision gears for high torque, high-speed operations without failure.
Makes sense.
So gear honing delivers that. It ensures optimal tooth contact, like making sure the load is spread evenly across the tooth.
Ah, preventing wear and noise.
Exactly. And perfect surface geometry. Absolutely critical in, say, your car's differential or complex aerospace gearboxes.
So it leads to smoother operation.
Much smoother and way better load distribution over the machine's life.
But it's not just about the quality, right? It's also efficiency.
That's a huge factor, yes. Honing, as a secondary finishing process, it's proving remarkably efficient.
More so than traditional methods, like grinding.
Often, yes. Compared to grinding or lapping, it can be faster and more cost-effective. It actually removes less material, but does it with greater precision.
Less waste, faster process.
Right, and we're seeing reports, manufacturers saving maybe up to 15% on energy in some cases.
Wow, okay. That's significant.
It is. Saves money, obviously, but also helps hit those carbon reduction targets. That impacts the whole supply chain.
Fewer reworks, too, I imagine. Better throughput.
Absolutely. It's a big win for streamlining operations all around. But, achieving that kind of precision, it's not without its challenges.
Okay, what are the main hurdles?
Well, one pretty significant one is the cost. The initial capital investment and setup.
These machines aren't cheap, then.
Not at all, especially the high-end ones, the CNC-controlled multi-axis machines.
Yeah.
You're talking substantial upfront money.
And it's not just the machine itself.
No, you also need specialized tooling, custom fixtures to hold the parts, and crucially, a team of highly skilled operators.
Ah, the human element.
Definitely. For smaller manufacturers or places with lower production volumes, that initial cost can be a major barrier, almost prohibitive sometimes.
That makes sense. So you mentioned skilled operators. What kind of skills are we talking about? Is it easy to train people?
That is an excellent question. And no, it's definitely not plug and play.
Okay.
Honing machines need very specific expertise. Operators have to really understand how to control speeds, feed rates.
The variables of the process.
Exactly. And critically, selecting and managing the right abrasives for the material and the finish you need.
Sounds like there's some art to it.
There often is, yeah. Finding that perfect sweet spot. So a lack of trained people or maybe weak technical training programs that can directly impact the gear quality.
And consistency suffers.
Precisely. Especially maybe in emerging markets where that specialized knowledge might be harder to come by.
And what about limitations? Can these machines hone anything? Or are some materials or shapes trickier?
Good point.
Yeah.
No, there are limitations. Honing is super effective on, let's say, traditional gear shapes and materials.
Yeah.
But its efficiency can drop when you're dealing with really hard alloys or maybe very complex internal shapes.
Like internal gears with tight curves.
Yeah, exactly. Or super hardened metals. In those cases, manufacturers might look at other options.
Like specialized grinding.
Specialized grinding, maybe even hybrid processes that combine methods. So yeah, that does limit honing's applicability in some very specific high-end scenarios.
Okay, so despite those hurdles, there must be some exciting stuff happening. What are the key trends pushing things forward?
Oh, absolutely.
Yeah.
The industry isn't standing still. One really major development is integrating honing machines with advanced inspection systems.
Automated inspection, like right on the machine.
Exactly. Think laser scanners, tactile
Yeah.
probes, checking the gear accuracy in real time.
Wow. So what does that enable?
It allows for adaptive control. The machine can actually correct deviations automatically on the fly.
Self-correcting machines.
Sort of, yeah. And it even helps with predictive maintenance. It's a huge boost for precision and just overall process reliability. And another really interesting trend is the move towards multifunctional modular honing machines.
Modular, meaning flexible.
Very flexible. Platforms designed to handle multiple gear sizes, different types, all on one machine base.
So better for varied production.
Perfect for job shops or high-mix production lines, places where you need quick changeovers and adaptability. They use quick change fixtures, multi-axis control. It's a big leap in versatility.
And looking ahead, you mentioned sustainability earlier. That seems to be gaining traction everywhere. How's that playing out in gear honing?
It's becoming quite significant, actually, particularly focusing on eco-friendly abrasive technologies.
Okay, what does that look like specifically? Recycled material.
Yeah, things like recyclable honing stones, biodegradable coolants are becoming more common.
And that's not just for show, presumably.
Oh, no, there are real benefits. Lower waste disposal costs, for one.
Right.
Reduces the environmental footprint of the whole process.
Smart business, too, then.
Absolutely. It aligns with global sustainability goals, appeals to environmentally conscious customers. It really does make a difference throughout the supply chain. And if you look at who's leading this, who the key players are.
Right, who's making these machines?
It's a mix of big global names and some specialized regional players.
Yeah.
You've got companies like Gehring, Dateweiler, Sunnen, Nagel.
Gleason, I've heard of them.
Gleason, yes. BVS Group, Kanzaki. These are highly influential companies.
And they're pushing the tech forward.
Constantly.
Right.
Through R&D, strategic partnerships, acquisitions. It creates a really dynamic, competitive landscape, which ultimately is good for the end users.
Wow. Okay, what a fascinating look into this intricate world of gear honing machines.
It really is quite something when you dig into it.
So just to recap for everyone listening, we've seen how that relentless demand for precision.
Driven by automotive, aerospace, and others.
Right. And the increasing complexity of things like advanced transmissions.
Needing those super precise gears.
And just the inherent efficiency of the honing process itself, all that is driving this market forward. But we also touched on the challenges. High costs.
Especially upfront capital.
And that critical need for skilled labor. Not easy hurdle.
Definitely not.
But then balanced by these exciting trends, automation, those flexible modular designs, and the growing focus on sustainable practices.
Reshaping the industry, absolutely. And if we connect this back, to the bigger picture for you listening,
Yeah.
understanding a specialized market like this, it actually offers really good insights into broader shifts in manufacturing.
How so?
Well, you see this relentless pursuit of perfection, of precision across the board.
Okay.
You see smart tech like that real-time inspection and adaptive control getting integrated into even traditional processes.
Right.
And maybe most importantly, that growing imperative for environmental responsibility. It's not just a sidebar anymore. It's becoming core to how things are made.
So maybe a final thought for you to take away. You kind of have a new lens now, right? To appreciate the engineering behind everyday things. So next time you're in a car, or you see some heavy machinery working, just maybe consider those tiny, perfectly honed gears working silently inside.
Doing their job flawlessly.
Exactly. Think about that precise process that made them possible, how it drives performance, makes things run smoother, last longer.
It really makes you think, doesn't it? How these seemingly small improvements in making one component.
Yeah, how they ripple outwards.
Exactly. Impacting entire industries and ultimately, well, enhancing our daily lives in ways we probably don't even realize most of the time.